This is Lab 25, Honors Chemistry, Ions in Solution. In this lab, you're going to take a collection of 13 different solutions, all made of aqueous chemicals, and combine them in all possible combinations, which you could do kind of at random, just by trial and error, but we're going to be really efficient. We're going to think about how we're going to do this, and even better, I'm going to give you a pre-made grid that will help you make sure that you get the right chemicals mixed together in every possible combination. So when you come into lab, you're going to find a red tray in which you will find 13 solutions, each one carefully labeled. When you select one, make sure you read and reread that label so that you know that you're using the right solution. Some of them look awfully familiar and awfully similar to one another. So here's sodium hydroxide, and then right next to it I have, another hydroxide, but this is ammonium hydroxide. So you want to make sure that you're using the right chemical at the right time. Now when you come into lab at each station, you're going to see this setup where this is a grid that follows the exact same format as the data table in the lab. So as I zoom in, you can see that at the top of each column, I have different chemicals labeled, and then as well down the side of the grid. And the piece of paper that is taped to the lab bench is covered by a piece of plastic wrap, which makes cleanup super easy. All you're going to do is to lay a paper towel down over the top of it, and then you can pull up the corners, which are just taped into place. You can pull them up and fold it over on itself and throw everything away. Cleanup super easy. Just wash your hands when you're done. So when you're ready to mix some of your chemicals together, select a bottle from the rack, read the label, sodium hydroxide, find its position on your table. And for me, I see that it's here. I already have some drops in place because I've already started this. And notice that there's a column marked sodium hydroxide, and then there's also a row marked sodium hydroxide. If you're smart, you're going to go ahead and use this dropper bottle in all the relevant places right away, and then you'll be done with it. You won't have to use it again. This will maximize your efficiency and take far less time to do the lab. So you're going to drop a single drop in place above the X in each square. The point and the goal here is to aim to get that drop to fall right over the X. I'm not doing a good job because I'm trying to film and do the lab at the same time. You're going to do a better job than I am. So you're going to put one drop in place, as I am, not letting the drops merge together as I am. I'm showing you what not to do, so you're going to do a much better job with that. When you're done with that bottle, make sure you screw the cap back on and then replace it, at least in the center of the lab bench, so that you can share with others. You can go ahead and grab another one. You can only do one, maybe two of these at a time, because you and your lab partner can only manage one or two, one each at a time. Grab another bottle, do the same thing. So copper sulfate, that means I'm going to put a drop in all of these X spaces, and then I'm going to do the same thing going across. So these four also get a drop of copper sulfate, and then that goes back and I try another one until all the X's are filled, at which point then you can start making observations using your data table. The only observation I would encourage you to really make note of as you're mixing the drops on the grid is if you see bubbles appear. Now I don't really have any here because I haven't mixed two solutions together, but you might see some little bubbles form inside the X. They'll show up against the dark black background, at which point you're going to grab your data table, and you'll notice in the bottom right corner the key for your observations is here. So if you see bubbles, you're going to put a B in the spot. If you see the reaction between H2SO4 and Ki, you see bubbles, so you're going to put a B there. If you see a color change, you're going to put C, and you're going to tell me what color. If it turns from blue to orange, you're going to write blue to orange. If it goes from light blue to dark blue, that's not a color change. That's just an increase of intensity of color. If you see a solid form, so that will likely happen over the X in the form of crystals. It'll look fuzzy, it'll look cloudy. Then you can put P for precipitate. A solid forms where there was not one before. So you know what to do as far as cleaning up in the end. One more thing though, before you clean up, once you have mixed all possible combinations, don't forget to do the challenge with your partner. It says place 10 drops of any chemical on your partner's unknown to your partner on the plastic wrap, I'm guessing you're not going to need 10 drops. I'm thinking 5 is plenty in an effort to conserve chemicals and minimize waste. So you would pick one of the solutions. Don't let your partner see what the label is. And you're going to put 5 drops. 1, 2, 3, 4, 5 down the side. And your partner's going to come over and select from the collection in presents on the table and use a variety of mixings to find out what that unknown is. Using the grid, you can compare what you know the reactions are to the ones that you're seeing on the sheet in front of you. And then trade positions. You do that for your partner, and then your partner does that for you. After you've done that, and you've each had a chance to be challenged, you can clean up with the paper towel over the plastic wrap and wash your hands. You're done.